Hello, students. It's April 21st, and I'm excited to help you read through some articles on energy. So let's get right to it. Again, just like motion, this is another word that we use all the time, but what does it mean in the terms of science? Okay. Energy. These young children are very active. They seem to be brimming with energy. You probably know lots of things have energy, from batteries to the sun. But do you know what energy is? Dun, dun, dun. Read on to find out. Defining energy. Energy is defined in science as the ability to move matter or change matter in some other way. Energy can also be defined as the ability to do work, which means use force to move an object over a distance. So that's what work means. When work is done, energy is transferred from one object to another. For example, when this boy below uses the force to swing the racket, he transfers some of that energy to the racket. Okay, into the ball. Standard unit for energy. Because energy is the ability to do work, it is expressed in the same unit that is used for work. The SI unit for both work and energy is the joule. Joule, not the shiny jewel. Or Newton times meter. 1 joule is the amount of energy needed to apply a force of 1 Newton over a distance of 1 meter. So you don't have to remember that exactly. Just know that joule has to do with movement. For example, suppose the boy applies 20 newtons of force to his tennis racket over a distance of 1 meter. The energy needed to do this is 20 Newton meters or 20 joules. Energy has many forms. If you think about energy sources, different sources of energy, such as battery and the sun, you probably realize that energy can take different forms. For example, when the boy swings his tennis racket, the energy of the moving racket is an example of mechanical energy. To move his racket, the boy needs energy stored in food, which is an example of chemical energy. Other forms of energy include electrical, thermal, light, and sound energy. The different forms of energy can also be classified as either kinetic or potential. Kinetic energy is the energy of moving matter. Potential energy is energy that is stored in matter. Okay, so we're going to get into those two terms in the next 2 chapters. All 3 of these chapters are pretty short. So question, is the chemical energy in food kinetic or potential? So if I have a bowl of Wheaties, is it kinetic or potential? The chemical energy of food is potential energy. It is stored in the chemical bonds that make up food molecules. The stored energy is released when we digest it, and we use it for many purposes, such as moving or staying warm. What is an example of kinetic energy? Anything that is moving has kinetic energy. They talk about the tennis racket. So this video kind of gives you an overview of what is energy. Now this guy has a lot of examples, and he goes into great detail about the conceptuals, the main concepts of what is energy, and hint, it's all around us. So pretty good, interesting view. You can go ahead and check that out. Summary. Energy is defined in science as the ability to move matter or change matter in some other way. Energy can also be defined as the ability to do work. And the unit we're always going to use is joule. Energy exists in different forms, such as mechanical energy and chemical energy. Most forms of energy can also be classified as either kinetic energy or potential energy. Okay, some questions here. You can take a look at them, but only a couple are going to be on that option 4. Okay, so this is just an overview of energy. Let's jump to the next one. You can pause here and watch that video. All right, kinetic energy 14.2. What could these 4 photos possibly have in common? We have a bee, race car, looks like a dam or waterfall of some sort, and something grinding metal. All of them have kinetic energy. Okay. Kinetic energy is the energy of moving matter. Anything that is moving has kinetic energy, from atoms in matter to stars in outer space. Things with kinetic energy can do work. For example, the spinning saw blade in the photo above is doing the work of cutting through a piece of metal. Calculating kinetic energy. Now, don't worry, this is just kind of an intro, so we're not going to be asking you math to calculate math problems in the assessment, but you will be seeing this in the future, so it's good to understand the concepts. So the amount of kinetic energy, or Ke, depends directly on its mass and velocity. As you can see from the equation, Ke equals 1/2 mass times velocity squared. So it's a direct correlation. The more mass or the more velocity I have, the more energy, kinetic energy I have. Okay? The equation shows an increase in velocity increases kinetic energy more than an increase in mass. So if I'm going super fast, my kinetic energy is going to go up more than if my mass went up at the same time because it's squared. Okay? So they have an example here of Juan. He has a mass of 40 kilograms and he's running at a velocity of 1 meter per second. Now in America, we have to adapt to be using the units for calculations. And for these, they're always in kilograms and meters per second. So you'll start to see that more often. And if you haven't already done conversions, then you'll see that later too. Okay. How much kinetic energy does he have if he's running at 1 meter per second? We plug those values in, his mass, his velocity, looks like a lot here, but it's actually just half of 40, which is 20, times 1. So at the end, we get 20 joules, always a capital J too. Okay. So, but what is a joule? A joule is the amount of energy needed to apply a force of 1 Newton. Oh, there's our unit of force, Newton, over 1 meter. So it's kind of hard to conceptualize, but if somebody is running like he is, he has the 20 joules, like in the example. So what about his dad? It says his mass is 80 kilograms. Well, let's just take a look. If little Juan is running on the beach and he has 20 kilograms and 20 joules, somebody is twice the mass, they're going to have twice the amount of kinetic energy as this one shows. Okay. Overview of kinetic energy. This video is for an AP physics class. So it introduces some different concepts, a little harder, a little more challenging, but take a look at it. It's always good to be exposed to these things, okay? A couple review questions. If you're wanting to, you can try out these calculations, but again, they're not going to be on the assessments. More about the concepts. Our last one, potential. What does that word potential mean? Well, you as students, you have the potential to go to high school, to start a career or go to college and do whatever your heart desires. You have the potential to do that. Same thing with energy. If I'm staring at a piece of wood or a piece of food, or I'm high up on the top of a cliff, I have the potential to transfer that energy into kinetic energy. And that's what we call PE, or potential energy. This diver has just jumped up from the end of the diving board. As she dives down and is falling towards the water, she'll have kinetic energy, or the energy of moving matter. But even as she is momentarily stopped high above the water, she has energy. Do you know why? Stored energy. The diver has energy because of her position high above the pool. The type of energy she has is called potential energy. Potential energy is energy that is stored in a person or object. Often the person or object has potential energy because of its position or shape. Question, what is it about the diver's position that gives her potential energy? Because the diver is high above the water, she has the potential to fall towards Earth because of gravity. This gives her potential energy. Gravitational potential energy. So much like the diver, we're looking just at that gravity component of it. Potential energy due to the position of an object above Earth's surface is called gravitational potential energy. Like the diver on the diving board, anything that is raised up above Earth's surface has the potential to fall because of gravity. You can see another example of people with gravitational potential energy in the figure below. It depends on a person's or object's weight, which we knew before. Oops. And it can be calculated with this equation. GPE, or the gravitational potential energy, equals weight times height. But remember, the definition of weight is not just what we say is how much do you weigh, that's the calculation of mass, but it's actually the force of gravity, right? So we'll have to go back to our lessons on motion. Consider the little girl on the sled. She weighs 140 newtons. On Earth, that's her gravitational pull. And the top of the hill is 44 meters high than the bottom of the hill. Now it's a tiny hill. As she sits at top of the hill, the child's gravitational potential energy is 140 times 4 is 560 Newton meters, which we know is a joule. Okay, don't worry about too much of these equations, but it's the concepts are going to be more important for our assessments. The gymnast on the balance beam weighs 360 newtons. If a balance beam is 1.2 meters above the ground, what is the gymnast's gravitational potential energy? 360 times 1.2 is 432 joules. Here's a little doodle science, 2 minutes long, and going over gravitational and kinetic energy. Take a look at that. Okay, our couple more things, and then we're all done. Elastic. When I think of elastic, what do you think of? A rubber band? Something else? Elastic waistband of your stretchy pants? Potential energy due to an object shape is called elastic potential energy. This energy results when an elastic object is stretched or compressed, like a spring. The farther the object is stretched or compressed, the greater its potential energy is. A point will be reached when the object can't be stretched or compressed anymore. Then it will forcibly return to its original shape. Look at the pogo stick in the picture below. Its spring has elastic potential when it is pressed down by the boy's weight and it springs back. The energy is released into the stick and for the boy, and boing, he's flying off. Okay, this one down here, she's pulling back the rubber of a slingshot, and she has a ton of stored potential energy. So when she lets that go, the elastic band will spring back to its original shape, and that rock is going to go flying. Okay. Some other forms of potential energy. Another Bozeman science video on AP Physics. Don't worry about the calculations, but the concepts are what you need to be thinking about. All the examples of potential energy described above involve movement or potential to move. The form of energy that involves movement is called mechanical energy. Other forms of energy also involve potential energy. Chemical energy and nuclear energy. Chemical energy is stored in the bonds between the atoms of compounds, like food, batteries, that piece of wood in that other video, and chemical energy. Nuclear energy is stored in the nuclei of atoms because of the strong forces that hold the nucleus together. That's how we get nuclear energy. Okay. Summary. Potential energy is energy that is stored in a person or an object. Doesn't get much more simple than that. what has the potential to express that energy. Gravitational potential energy is due to the position of an object above Earth's surface. The object has a potential to fall due to gravity. It depends directly on the object's weight and its height above the ground. Elastic potential energy is due to an object's shape, like a spring, rubber band, elastic band. It results when an elastic object is stretched or compressed. The more it's stretched or compressed, the greater its elastic potential energy is. Chemical energy and nuclear energy are other forms of potential energy. Okay, a few review questions. That one about food is going to show up on your option 4 write-up. So let's go to that. Hopefully it looks just the same as it's going to be in the final version. Please write these definitions. Just 4 terms, the big ones right there. What is energy? What is KE? What is PE? And what is a joule? 2 questions for you. Why does food have potential energy? What happens when you burn wood? And here is compare and contrast gravitational and elastic potential energy, just like you said, and give some examples of each. Going down here on the next slide, I'd like you to go through all of these and say, is it potential or is it kinetic? Because you really got to get the difference between these two, especially if you're going to start doing equations in physics in the years to come. P or K? I put an example right there. That's it for me. Thanks for listening, and stay safe. Bye-bye.